All right, in this video, we're going to sketch the graph of translations of the log function Okay, so here I'm going to sketch the graph. Well, I will say that as a math person, I sort of just want to use the natural log. The natural log is base e. Y equals ln x is the same as y equals log base e of x. E is Euler's number, and it's around 2.718. So I'll write it like this, 2.718, and it keeps going with different digits, with different numbers there, without a pattern, with the different digits. You know, there's no pattern. It's Euler's number. It's an irrational number. Okay, so we've talked about this in another video of what this graph looks like. Roughly speaking, this is it. I'm focusing on the vertical asymptote and the x-intercept. So that's sort of our starting point. And if I change this to base 10, which is the common log, or base 2 is another maybe well-known one or often used one, you would get something really similar. So now let's look at y equals ln of x minus 2. What does this do? This is a shift right by 2. So this is true for any graph of a function, is that if you exchange x by x minus 2, it shifts it 2 to the right. Okay, so what I want to do is I want to focus on the vertical asymptotes and even label that. Vertical asymptote is x equals 2. And I want to focus on the this x-intercept also. It's 1, 0 here. So on our original graph, y equals ln x, I have 1, 0, and then over here, I'm going to I'm shifting to the right, so I add 2 to all these x values. So shifting to the right adds 2 to all the x values. So this gets x equals 2, and then 1 plus 2 makes 3. And so that's the x value I have here. All right. So, well, let's do one where we shift to the left, might as well. Let's do common log. Okay, so let's do x plus 1. So y equals log x is the common log. It is the same as y equals log base 10 of x. They're the same. It occurs to me I should have written down y equals ln x is the natural log. I said it, but I didn't write it down. Okay, this is a shift right. No, shift left by 1. So we draw the graph of logarithm, but the vertical asymptote for the unshifted, so the original classic y equals log x, that vertical asymptote is the y-axis, which is x equals 0. If I shift left to 1, I get x equals negative 1. And okay, so what I'm going to do over here is go up here. This is base e, but you're going to get a lot of the same things here. X equals 0 is the vertical asymptote, 1, 0. This, by the way, is the natural logarithm. Okay, So if I shift to the left by 1, I subtract 1 from all those x values. So in particular 1, 0, and I subtract 1, I get 0, 0. So those are the things I want to focus on, are those vertical asymptotes in the x-intercept. Just there's one vertical asymptote in the x-intercept, but also the general shape. Okay. Now we're going to do one that's maybe a little bit tricky, but we can do that, which is, this will be D. Suppose I have y equals ln and I have negative x. Well, what does this do? Okay, the graph of y equals f of negative x is a reflection about the y-axis of y equals f of x. So what I can do is just draw the logarithm graph, but so I can draw the logarithm graph. I mean, this is, yeah, same thing, right? This is natural ln x. This is ln negative x. I draw this, but I have a mirror image around the y-axis. Now the thing is, yeah, I mean, you could check on the calculator. I've had students who, when I tell them this is true on the test or something, they don't believe me until they check on the calculator. So that's fine. You can check on the calculator. Another way is that we could really break this down by plotting points, but it's difficult to plot points with base e. So you could plot points with base 2, but it's not really all that easy too. You have to really understand logarithms to be able to do that. But anyway, this is the domain. I mean, this is the graph. Actually, what I was thinking about is what's the domain here. The domain is all x less than 0. We can see from this picture. We might as well go back and look at the domain of these others too. So for this C, or let's go all the way over here to A. So this would be the domain is all x greater than 0. I'll just write this 0 to infinity. So but see, it's round, so we don't include 0. So it's x greater than 0. What I mean is the parentheses is a rounded one. Here the domain is x greater than 2, so you could write 2 to infinity. And because we can see it's never going to hit that vertical asymptote. In here the domain is, okay, well, for one thing I caught a mistake. As we can see, this is not 1, this is negative 1. So the domain is negative 1 to infinity. Alrighty, so that's, I think, where we'll stop.